Hello, Assalamu alaikum. I am Junayed and I am a student of Daffodil International University, Department of Computer Science and Engineering. I am from section 65B1 and my ID initial is 105. Today we are going to talk about some algorithm strategies and two of the mainly algorithms that are binary search and bubble sort. Binary search is actually under divide and conquer algorithm strategy, and bubble sorting is under the algorithm strategy of brute force. Now I am going to explain the binary search code, and I will also use the visualization technique for better understanding. Let's start it. Here we can see our code for binary search. As I said, the binary search is under the algorithm strategy of divide and conquer. Here the problem is searching, and we are using binary search algorithm which uses the strategy of divide and conquer. Let's start from the coding part. I am using C programming, and we all know that C programming starts initiating from integer main, the main function, and I already declared some variables which we will use in our further code. And let's go further. We are taking a value for the array size, it is n, and we are taking a low of 0 and high of n minus 1. This is one index lower from our initial size of array, the n. And why are we taking low and high? Let's go into the visualization part. Here, the visualization of binary search. Initially, we are going to search 23 in our code or in our array. Let's see. Here is an array, but there is a condition for binary search. The first thing we have to do is sort the array. The array must be sorted in order to do a binary search, and we will explain why we need it to be sorted. This is an sorted array. This array is sorted. I already sorted this array. This one is the sorted array, and the 0 index and 9 index, we have the n size is 10 here. We already have 10 arrows we already have 10 values in the array. Now let's go. The low key, we determine the index 0 as low, and the index the n size is 10, n minus 1 is 9, and the index 9 is our last index, and we determine it high. We already assigned it in the code as low 0 and high n minus 1. Now we are going to take the array. For taking the values of array, we are going to use a for loop and scan all the values in the array index by index. So we already have taken the array, but the array is not sorted yet. If the user gives an unsorted array, we have to sort it first. So this part of the code does the sorting part. This for loop is for running the loop several times to n, from index 0 to n less than n times. And this inner loop will run from j is equal to I plus 1. Wherever the value of I will increase, it will increase by 1, and it will run till it's less than n. This if condition will check if the first index or value of the first index is already better than the second index. If our first index is I here, and the second index j is equal to I plus 1. I plus 1 means the next index of I is j. We will check if I is better than j. If I is better than j, we cannot sort it in an ascending order. if it is already in a descending manner, so it will we will change the we will assign the first index in M, and then we will assign the second index j in first index. We will assign the second index j in the first index, and M, the first index value, in the second index. With this, we will get shortly this: the second index goes to the first index and the first index goes to second index. We will do it consecutively, the second index with the third one, then with this one and this one, and with this one and this one, and with we will go further. But it is not sure that the first pass of our sorting will completely give us a sorted array, so we are going to do this sorting part again and again till we check the last index with the outer loop. There the sorting part is done. Now we will print our sorted array with this for loop in order to see if our array is perfectly sorted, and then we will take a scanf from the user in order to search which value I want to search in our array, which value location or which value I want to search in our array. Then I will use a function binary search, shortly bins. I used bins as a short form in order to find our searching element. We already sent array, the low variable, the high variable, and the searching element k variable to our binary search function. Let's start the function here. We will initialize a variable named mid. Why we need the mid? This is the mid of our array, the mid index of our array, and in order to get this, we will use this formula low plus high divided by 2. Here we will get our mid, and if the low index is 0, the high index is 9, as we see here, and they are divided by 2, it will give us the 4.5, and it is an integer, so it will get 4. This is our mid index. Now we will check if the low index is less than or equal to high index. The low index is 0 and the high index is 9. Yes, the condition applies, and then we will have a nested if the mid value is equal to our searching element. We will use this condition for our further use. Mid is equal to k. If the mid is equal to k, we already found our value 23. But in our first step, the mid is not equal to the k or the key. So we will check if the key is better than or less than our mid. Here 23 is better than our mid 16. For that, as we already know, this is a sorted array. A better number than 16 cannot be in a lower index. So we will stop looking into the lower indexes, and with this we already divided our array in 2 parts, and we already neglected the first part. This algorithm strategy is called divide and conquer. Now our low is equal to 5. As our mid was less than k, we already changed our low into mid plus 1. We already had a new low with mid plus 1. We assigned it in our new low, so it is the new low, and this is the high. We will use the same condition over again, and we now get the mid as 7. Now we will check the mid if it is equal to k. No, the mid is equal to 56, and this is far more greater than k. Now with the same condition as this one, we cannot have a lower value in the array which is better than the mid. So we will neglect this part now and we will start working on this part. Now again we will do the same thing. As the mid is greater than the k, as the mid 56 is greater than our key 23, so we will now assign the high part, assign the high into mid minus 1. With this we will get mid minus 1, the mid is 7, minus 1 is equal to 6. The sixth index will be our new high. There we got our new low and new high. Then we can get our new mid over again with this formula, and this time the mid will be low 5, 6, 5 plus 6 is equal to 11, and divided by 2 is 5.5. We have this integer, so it's 5. The mid will be the same as the low. Now with this condition, mid is equal to k. K is equal to 23 and mid is equal to 23. Now we already found our desired element, and if mid is equal to our key, we will print the index of that element, and with this condition to be true, we already found our element. But what if the element never existed in this array in the first place? With this check, we already have our mid is equal to k and we got our element. But what if the element never existed in this array? Now let's see what would happen if the 23 was not available here. Then we would have used that the mid is better than or less than key. Then we would have used this formula and change our low, and this formula to change our high. And if the low becomes better than high, if the low, here our low is 5 but low becomes 6 and the high becomes 5, then and this else if condition will be initiated, and we already have searched all the possibilities and couldn't found our desired element, so it will show us that not found. And this is how our divide and conquer algorithm strategy works. So we already found our desired element, and we already explained that what would have happened if the element didn't existed in this array in the first place. So this is it for the binary search. Now we will talk about bubble sorting, and bubble sorting is the algorithm strategy brute force. We will search for almost all the possibilities, and sorting is the problem here, and we have to sort this array in a ascending or descending order. We are going for the ascending order. Let's start from the coding part, and we will start from the main function as it is a C program. We already assigned some variables named num, x, y and temp. We will further explain why we used this temp variable. Now let's take the scan for the size of our array as number, and we take an arr as the array, and we will use this for loop in order to take our array values. Now we will use a function named sort and send the array, the number as the size of our array, the x, y and temp variable to our function. In this sort function, we will use a for loop initialized with the 0th index, and we will read it till the number minus 1, till the we will read from 0 to number minus 1. The number here is the array size. We take if we think about this visualization, there are 5 elements, and 5 elements means number is equal to 5, and number minus 1 means 4. The fourth index 0, 1, 2, 3, and fourth index, and less than 4 means we will read it from the 0th index till the 3rd index. We don't have to read till the final index, because we already have in the code that we will check the next index of y. If we check the 3rd index, we will also check the y plus 1, 3 plus 1 4, and the 4th index, 3 plus 1 4, the 5th index. So we don't have to read it till the final index. Now let's go to the nested for loop. We will read it with the initialized value of y as 0, and we will read it till the number minus 1. Number minus 1 means 5, number minus 1 means 4, and we will reduce the value of x from here. If the value of x is 1, then it will be 3. We will read it till the 3rd index, and if the value of x is 2, we will read it till the index 2. Now let's start it. What we will do here, if our first index is better than second index, if the first index is better than second index, what we see here is yes, 5 is better than 1, that we will do the swapping process. We will bring the second index to our first index and first index to our second index. If it's not better than, or if the first index is not better, then it is already in a sorted from here, and we don't have to do anything here. And in this case, the first index is better than the second index, so we use a temp variable and put our first index. Let's remove these 0, 1. We will put the first element in temp. In order for the swapping, we will initial the first index in temp, and then we will use y plus 1, means the first index plus 1 is the second index, and we will assign the second index in our first index, and then the first index we assigned in temp in the second index. With this, we already have the first in the temp, second in the first, and temp in the second, which will finally lead to second in first and first in second. We already swapped it here. And then we will get 1 here in the first index and 5 here in the second index. Now in the loop, we will now check. We already checked 0 and 1 index. Now we will check 1 and 2 index. If the condition applies and we need a swapping, that we already swapped here in the same swapping process. Now after checking that 1 and 2, we will check that 2 and 3. If the condition applies, yes, the condition applies here, we will then do the swapping part. And now the third and fourth, here we can see that the first index is less than the second index, which does not require a swapping, so we will keep it like as it is. Now we already finished our first pass. We already sorted it a bit, but we can see that the array is not completely sorted. Where we can see we have 4 after 1, which is better than 2, and it is not to be, and this does not say that it is sorted. So we will go to our second pass, and for this second pass we use this outer loop. In order, if we completed the first pass and approximately sorted it, we have to read all the other possibilities and determine the complete sort. Now let's go to the second pass, and we will start checking from the first index again. Now if the condition follows. Now that the condition is false, then no swapping is needed. Then we will do it for the 1 and 2 index. There the condition is true, so there needs a swapping way, and we already got our 2 and 4 in a sorted manner. Then we will check 2 and 3 index. Yes, the condition is false, so no swapping is needed. Then 3 and 4, the condition is false as 5 is not better than 8, so swapping is not needed. We already got another sorted array. Here we already got our sorted array, but the interesting thing is the outer loop will read it till the end. Here we can see for the outer loop we will use passes, as the first pass is done, second pass is also done, but the outer loop says it will read for number -1 for 4 times, and it will also check the, even though we already got our sorted array in the second pass, but it will read it 2 more times and complete its 4 rounds. So we can see here that in third pass we will check it over and over again. 1 with 0 with 1, no swapping needed. 1 with 2, no swapping needed, as all the as the conditions are false. 2 with 3, the condition is false. 3 with 4, the condition is false, but we get the previously sorted array over again, and we will use the fourth pass also, but the array is already sorted and we will get this answer over and over again. So our bubble sorting is complete. We can see the conditions, and the same thing we said, that the first index goes to the temp, and the second index means first index plus 1 goes to the first index, and the temp goes to the second index. This is the swapping process, and we will do it over and over again to get our final sorted array. This is all from bubble sorting, and this is all from me today. I hope you understood the binary search and bubble sorting. Thank you. Assalamu alaikum.